Ladies and gentlemen, welcome to It's Rainmaking Time and this special segment on the truth about weather and climate. I am clear that we will not be in possession of the total truth about weather and climate for some time, but I can promise you we will have the necessary grounding, that which is necessary to truly inquire about this subject, and we will have the tools to decipher facts from fiction. True inquiry and scientific process is actually hotter as a subject than, quote, global warming and, quote, climate change. The business of science is actually hotter than what's going on with weather and climate. And what's interesting is that they're fused. They're going on in a connected fashion, even though they're parallel things going on. It's fascinating and it's very controversial. So it's best to sit back, put on your seatbelt, relax, and think that you're flying on a starship with a passionate scientist with 20 years plus of training and loves his field. Ladies and gentlemen, Willie Soon is an astrophysicist and a geoscientist at the Solar, Stellar, and Planetary Sciences Division of the Harvard-Smithsonian Center for Astrophysics. He is the receiving editor in the area of solar and stellar physics for New Astronomy. He is the author of the Maunder Minimum and the Variable Sun-Earth Connection. He is the receiver of the Peter Beckman Award for Courage and Achievement in the Defense of Scientific Truth by Doctors for Disaster Preparedness. He is the Chief Science Advisor to the Science and Public Policy Institute. Ladies and gentlemen, welcome Dr. Willie Soon.
Thank you, Kim. It's a pleasure to be here.
I thought, because we've covered in part one of this look at climate and weather and what is this global warming phenomenon and new laws, what are they about and why is this happening and what is the true science and what is the erroneous science and what's even happening to science. I interviewed a meteorologist and another climatologist and an author of 2 books, Robert Felix, and I thought that a perspective from an astrophysicist would be useful today to distilling what is the distinct perspective an astrophysicist has on this subject of climate and weather?
Okay, that's a very good question. Let me start by saying that, first of all, we know that in terms of the energetics, the energy that is available for basically the ocean current to move or the air current itself to move or even the tree to grow, things like that, it's all essentially given by the sun. So therefore, I guess for someone who's studying the sun for a while, it would be very useful to add the perspective in terms of how, in terms of the energetics in the Earth climate system would change or varies. And then, as somebody who's been also thinking long and serious about this question, then I really think that the insight from what we have learned about what the sun has been doing in terms of how its light output has been changing over 1,000 years or even 100,000 years or even millions of years would be, of course, important in terms of trying to really get at the true understanding of how the Earth weather and climate system would work. I would start with a very simple basic, even it's actually somewhat surprising sort of a question that if you ask to the lay audience or maybe even to you, Kim, yourself, how many % do you think the carbon dioxide in the air do we have?
I see. Before we even go to that, and that may be the question, before we even go to that, may I go back and start you a little bit more for a beginner who has no entry point, no context, no frame of reference for anything about the sun? Can we go back to that and then go back to the CO2 part?
Sure.
Okay. Go ahead. Talk about the sun, the distillation of what the sun's activity has on climate as we know it.
Yes. The sun, as we know, is basically the main energy source for all the available energy in the climate system. There is no doubt that whatever the sun does, however minute, even just the fact that the Earth going around the sun every single year produces that season. And then I would even go further and claim that a lot of the current confusion about how the weather system and the climate system work is basically caused by the lack of our ability to try to truly understand how even the seasonal cycle work. And the sun itself, of course, is not a constant light bulb like the light bulb you have in your room, who's just shining at the constant energy source that is not changing at all. To the contrary, we, after basically 400 years of study, starting with Galileo Galilei, that we have learned that essentially the sun is the imperfect light bulb with a lot of basically stuff that is coming and going in its surface. These stuff are essentially things that are known as sunspot, for example, the magnetic sunspot, because sunspot is essentially a magnetic structure that is built on and made up in the sun itself.
Is a sunspot, I want to clarify a few things for the listener. Remember, we're establishing a frame of reference together. And so if you could help me with them, the sunspot is what? Is that the center of the sun? What is a sunspot?
A sunspot is darkened areas on the surface of the sun that is essentially, the reason why it's darkened is because of the magnetic field that is extremely strong around the region. That is close to about 10,000 times at least stronger than the average Earth magnetic field, for example. And the reason why it's dark is, of course, because around strong magnetic field region, hot gases would not be able to flow very well around there. So it sort of appear a bit darker relative to the brighter background. And the fact that we have sunspot, and then we have also basically not only sunspot, of course, the dark magnetic structure, we also have extremely bright magnetic structure as well. So these are the few of the features on the sun that actually would sort of attack a war within these features that would actually govern how much sunlight actually is given out by the sun itself. And of course, once the sunlight reaches the Earth, that will serve as the input or the energy input to the Earth climate system. And after 400 years of learning, we do find that indeed these magnetic structures on the sun, magnetic features on the sun, do change quite a bit. A bit in the sense that it is more than enough to try to explain most of the changes that we have been able to measure and deduce on the Earth climate system. Meaning that if the Earth temperature that is changing by, let's say, even 2 to 3 degrees centigrade or 4 degrees Fahrenheit, the energy output given by the sun is more than sufficient to explain those numbers.
Can you explain something too? I'm sorry, don't mean to interrupt you, but can you explain when you said a few minutes ago that the sun is like an imperfect light bulb? I would think the average person would think it's a really great light bulb. Why did you say it's an imperfect light bulb? That's an interesting comment.
It's imperfect in the sense that people expect this sun to be that smooth sphere, right? I mean, the whole concept of everything being a smooth and perfect sphere with no features or whatsoever. In fact, we even know that the sun, because of the magnetic field, that is able to espouse huge amount of gas actually that is being out from the sun that actually could affect the telecommunication or the GPS or the cell phone that we are using.
The gas that the sun spews, is that what people refer to called flares?
Those are called flares, and sometimes it's also called coronal mass ejection. That is close to 100 billion cars if you measure in terms of the amount of material that actually came out at one shot in a matter of minutes and hours that this stuff could spew out from the sun, and then eventually, of course, it reaches the Earth's upper atmosphere where it interrupted most of the functioning of how the magnetic field and airflow current at the top of our atmosphere. This is why the impact of the sun on our Earth system is extremely obvious in many, many ways. And it is somewhat, of course, surprising then when it comes to the discussion of the Earth climate system is that somehow we know all that, and that all of a sudden when people started to discuss about the carbon dioxide emission from the use of natural gas, coal, and oil that we do for our daily life. And all of a sudden, people say that the forces of the sun would no longer be important. And then it is indeed that they say only the carbon dioxide